Hello, students, and welcome to our lesson on inequality. So this is Unit 7, Linear and Quadratic Inequalities, and we're going to do Lesson 1 today. So just a reminder, there's always that checklist of practice work. If you have any questions, let me know. So before we even get started, let's just recall what we already know about linear inequalities or inequalities in general. These are things you actually have seen before, but maybe you didn't know what they were called. So an inequality involves signs like this. So less than or equal to, greater than, or equal to. The sign, the inequality, always opens up towards your larger value. I always learned it as the crocodile going nom nom nom, or you can think about it like Pac-Man. Those Pac-Man villains going to go eat, or you are the Pac-Man going to go eat the goodies. It always opens towards the larger value, and you always read it from left to right. So in this case right here, you have something on this side, it is less than something on this side. So that's the less than or equal to symbol. Right, to solve an inequality or linear inequality is basically the same thing as solving any kind of linear equation. You're going to use algebra. The only extra little tidbit is if you divide both sides by a negative value, you are essentially changing the signs of all values, which means you also have to change the direction of the inequality. And that's really the only catch. So in example 1 here, we're going to do A and C, which do not involve that extra little catch. So I'm going to go through A to, right now, and then you are going to pause the video and try C on your own. All right, so with any kind of algebra, the first thing you want to do is look for simplifying each side first. Both of these sides are as simplified as possible. The next thing you're going to look to do is move all the x's onto one side and move everything else to the other side. When you start to manipulate, moving things back and forth, you are trying to solve by algebra, which is kind of like deconstructing and working backwards from how you would calculate something. So when we calculate, we follow BEDMAS, the order of operations. When we are solving by algebra, we are working backwards. So we want to do all the adding and subtracting stuff to both sides first, then the multiply and divide to both sides next, and then deal with the exponents and the brackets last. Okay, so with this one, I'm going to subtract x from both sides. So that's a really funky looking negative there, but you know what I'm talking about. So I'm going to end up with 7 plus 4x is greater than or equal to minus 1, because x minus x is 0. And then I'm going to get rid of this 7. So I'm going to subtract 7 from both sides. So I'm going to get 4x is greater than or equal to negative 8. Now I've done all my adding and subtracting. I'm going to get rid of that 4. The opposite of multiplying by 4 is to divide by 4. So I'm going to divide both sides by 4 to remove that 4 from the left-hand side, leaving me with just one positive x is greater than or equal to negative 2. Okay, so if I were to put this on a number line, we have a 0, we have a negative 2, we have a positive 2 over here. Because it can be equal to negative 2 is included in our solution. So we will do a solid point, and then everything greater than this point is also possible solutions. And that's how we would represent it on a number line. All right, so pause the video here and try C. All right, welcome back. Hopefully you got to flex some of your rational equation skills. Here we have a rational inequality. So the first thing we want to do is get rid of those fractions to make it easier to work with. So I'm going to multiply everything by 6 because that's the lowest common multiple of 2 and 6. All right, so that's going to be 6 times x plus 2 over 2 is greater than 6 times 3 minus x over 6. I apologize, I forgot to change colors. So 6 divided by 2 leaves you with 3. X plus 2 is greater than, that cancels out and leaves you with 3 minus x. Okay, so the next thing I want to do is I want to expand my brackets to simplify both sides and also work on moving things around. So that's going to give me 3x plus 6 is greater than 3 minus x. Okay. So next step, I've simplified both sides as much as possible. Now I want to get all my x's onto one side and all my numbers onto the other side. So I'm going to do the x's first, but really the order of which you do these two things, it doesn't matter. So I'm going to add x to both sides first. You can also do them all in one step, but I'm going to break it down. So that's going to give us 4x plus 6 is greater than 3. I'm then going to move the 6. So I'm going to subtract 6 from both sides. I'm going to keep going because I don't want to do any video editing. So then it's going to be 4x is greater than 3 minus 6 is negative 3. And the very last step is to divide both sides by that positive 4. Because it's a positive that I'm dividing both sides for, nothing changes. X is greater than negative 3/4. There's a negative in there. I just kind of got a little sloppy. All right, so on a number line, I would have 0 here. I would have -1 here. I would have +1 here. Because that would be a half, that would be like 3/4, that would be 1/4. So because it's x is greater than negative 3/4, but not equal to, negative 3/4 is not a part of the solution. So we represent it by a hollow point, like a hollow circle. We do not fill that circle in. And then of course, everything greater than negative 3/4 can be a part of that solution. Okay. So the next example is exactly the same thing, except for we're going to end up dividing by a negative value. Remember, dividing by a negative changes the sign of every single term. So because we're changing the signs, we have to change the direction of the inequality as well. So I'm going to show you an example, and then I want you guys to try the next one on your own. We're not going to do B, we're just going to do A and C. So the first thing I'm going to do is isolate that negative 2x. I'm going to subtract 5 from both sides, because remember, we're working backwards, so we want to do all the adding and subtracting first. So we get negative 2x is less than negative 12. So that's negative 2x. And so now we're going to divide both sides by negative 2. And because we're dividing by negative 2, this x is now becoming a positive term. So we need to change the direction of the sign, because we're no longer solving for the negative x, we're solving for the positive version of x. And negative 12 divided by negative 2 is positive 6. All right, so if I were going to represent this on a number line, 5, 6, 7, we have that x is greater than 6. So 6 is not a part of the solution, so it's a hollow circle. And then everything above is a possible solution. Okay, pause the video here and try C. Welcome back. So the next thing we're going to do is, the first thing we're going to do, sorry, with C is we're going to expand those brackets and simplify our left and right side as much as possible. So I'm going to multiply everything by that negative 2x that is in front of the bracket. So negative 2x minus 10 plus 10 is greater, that's a 10, not a 16, is less than or equal to x minus 6. Okay, so negative 10 plus 10 cancels out. I just love it when that happens, leaving me with negative 2x is less than or equal to x minus 6. The next thing I want to do is subtract x from both sides. So I get negative 3x is less than or equal to negative 6. This is my C work over here. And the next thing I'm going to do is divide both sides by negative 3. Because I divided by a negative value on both sides, I need to change the direction of my inequality, because I'm no longer solving for a negative x, I'm solving for the opposite, the positive x. And negative 6 divided by negative 3 is positive 2. So on a number line, 0, 1, 2, 3, I would fill in the 2, because 2, it can be equal to 2. 2 is a part of the solution, and it's greater than. So once again, it's everything above. I just realized all my examples were greater than. If it was less than, you would do the arrow in the opposite direction. Okay. So the next thing I want to talk about is discrete and continuous data. So for all the examples I've done above, they were all continuous data, meaning that all the values above or including that point were possible solutions. But sometimes you can't have possible solutions that exist between values. So for example, you can't have 0.2 of a person if we're talking about population dynamics. You can't have 0.3 continuing of t-shirts if we're talking about marketing or sales. So discrete means that their partial values are not possible. When partial values not possible. Okay, so these are going to include solutions where you have x can be an integer, so it can be a negative value. X can be a whole number, so all our counting numbers plus the number 0, and then x can be a natural number. And we tend to use these a lot when we're talking about real life. In real life, you can't have negative children, you can't have negative weight, negative height. So things that occur in the natural world are always going to be in the positive. We do have values that go into negative, of course, when we're talking about direction in physics and vectors. Okay. So continuous data is when partial values are possible. So you can have decimals, you can have values that exist in between. This is for things like time does not have actual discrete values, time just keeps going. You can have values for like weight that can exist in between. You might not have negative weights, but you can have weights that exist between 1 pound and 2 pounds. You can have 1.5 pounds. You can have 1.3333 pounds. You can have things like that that exist. So those would be examples of continuous data. So for growth charts, we would use continuous data. All right. All right, so the next one, we're going to just talk about how we can represent inequalities with algebraic statements and how we can do it with words. We're going to do the first and last diagram in here. So for this first one, as you can see, if the purple line represented an inequality, it's focused around this 5. So x is greater than that 5. So you can say it in many different ways. You can see it represented as x is greater than 5. You can see it as x is greater than 5 and all the way to positive infinity. You can see it represented like that. Or you can see it represented as 5 and then a comma and then infinity. Always has a curved bracket because it never actually equals infinity, because infinity just keeps going. That's the whole point of infinity. So we use curved brackets for is not equal to, and then square brackets for when it is equal to, and I'll give you an example of that later. So how you would say this with words is x is greater than 5. Okay, so that means anything greater than 5 is a possible solution. And again, you can represent it in any of these 3 ways. I will accept all 3. That last way, though, is what you're going to need to use for if you continue on with your math learning. This last one, I want you to pause and try this one on your own. So hopefully you did, and that went well. So here we still have the value 5 as being a crucial point here, but do you guys see how the circle is filled in? So that means x can be equal to 5 as well, and it's going to be less than. So x is less than or equal to 5. And of course you can represent this in a stream. So it is less than or equal to 5. And of course, it has to be involving negative infinity, goes down to negative infinity. And how we represent that in the other method is it's a circular bracket, infinity to positive 5. And because it can be equal to positive 5, instead of using a circular bracket, we use a square bracket. And how we say this as words is x is less than or equal to 5. All right, for this last one, we're just going to do the first one. It says solve the inequality. Actually, no, we'll do both, but I'm just going to give you the solution for the second one. So for the first one, again, you're going to simplify all the sides, just like we did for example 1 and 2 on the previous page, and then you're just going to stick it on a number line. So this is extra practice. Okay, so we're going to expand those brackets first. So we get 2 plus 3x plus 6 is greater than x plus 16. Then we're going to simplify that left side. So 3x plus 8 is greater than x plus 16. And then we're going to move all our x's to one side and all our numbers to the other side. I'm going to do this in one step. So I'm going to subtract x from both sides. And I'm going to subtract 8 from both sides. And I'm going to end up with 2x is greater than 8. And then I'm going to divide by 2. And I'm going to get x is greater than 4. So on the number line, 4 is the crucial point. So I'm going to circle it. I'm not going to fill it in because it cannot be equal to 4. And then I'm going to draw my arrow in this direction. All right. I want you to pause the video and try B. The number you should have got is that x has to be less than -3/2. Right, so -3/2 is the same thing as -1.5. So you find where 1.5 is, it's roughly there. This is not precise graphing, obviously. You are going to circle that important point. You are not going to fill it in because it cannot be equal to -1.5. And then because it's less than, you're going to go draw your arrow in this direction. So I hope that helps. Again, the textbook for this section will have examples in it as well. It's chapter 9 in your textbook, so you can always look to your textbook for extra explanations. And you are going to complete the lesson 1 handout. I hope that was helpful. And I hope that if you have any questions, that you please ask me.